Hello community! Today we go agentless for software development. And you know, up until now, all the AI research community developed autonomous agent. Autonomous agent to perform an end-to-end software development task. And we equip those agents with the tool use, they can run commands, get feedback from the environment, and plan their future action, the pure definition of what an AI agent is. And you know those agent-based approaches. You know Devon or OpenDevon, the open source alternative. You know SWE-Agent, or you know maybe AutoCode Rover. All of those systems are agent-based. And here, for example, a system that I like, Ada. And here from June 2024, Ada is state-of-the-art for both SWE-bench and SWE-bench Lite. And you see here the performance here. If you use here Opus as your LLM for SWE-Agent, or GPT-4, or you go with Amazon Q Developer, the agent, or you go with Devon, and then you see the performance, for example, of Ada. Plus, I do like intelligent people when they say, hey, it is interactive, not agentic. Plus, of course, open source Apache 2 license, and you can run it here on a MacBook, plus Claude 3.5 Sonnet, and it is compatible with DeepSeek Coder version 2 already. What a nice approach. But now we have some researchers from the University of Illinois, and they say, hey, the complexity of those agent-based approaches, together with our real limited abilities of the current LLMs that we discover more and more with the hallucination and, it raises for us a simple question. Do we really have to employ complex, autonomous software agent for software engineering, like we had to do 2 years ago? Do we still have to deploy agent for this task now that we have some advanced technology at our hands? Imagine a world where in software development we would not need agents. Yes, of course, the whole industry sector who is pushing and selling AI agent in software development will say, hey, wait a minute, no, we invested millions in their development. But we are a research channel. We ask what is possible with the technology and what is the latest research. And maybe the latest research shows us that an open source code is outperforming all the other open source agentic solutions. And here we have it. July 1st, 2024, Agentless, demystifying LLM-based software engineering agents. And they develop Agentless, a simplified approach to solve software development problems using LLMs without the complexity of autonomous agents. And you know what? Before we dive into anything, let's see at the benchmark data. I want to see the performance of those systems before we have a look. How does the system do it? So, what is the result of this? Yeah, open source software development. We have here, we start with the tools and then the supporting LLM. Open source, Ada, AutoCode Rover, SWE-Agent, OpenDevon, plus RAG systems. And then, in the last line, you see the new Agentless. For the LLM, we go with GPT-4 Omni plus Claude 3, or only GPT-4, only Claude. You choose whatever you like. But now let's look at the performance of the percentage of the resolved task of this software development benchmark. And you see from all the open source tools, the very last line with 27.3%, Agentless has a better performance than all the other open source tools that use agents. Now this is interesting, and the authors also argue that given their cost structure, if you have to deploy Claude 3 or GPT-4 Omni, is also absolutely compatible if sometimes you look here at this, their cost base is 1/10 of other open source systems. So interesting. Maybe this is something we should have a look at. Now let's be clear, if we go now to professional, proprietary, very expensive business solutions, we have here Alibaba, we have IBM, we have ByteDance, we have Amazon Q Developer. If we look at those systems and we integrate those now, these proprietary closed systems, with GPT-4 Omni plus Claude 3.5 already, we see the current Alibaba system, Lingma Agent, is best in class with 33% resolved tasks. But you know what? If we now compare this to the very last line, Agentless, with 27.3%, you see there is a difference, but the difference is not that monumental. Because look, we just need to go down 1, 2, 3, 4 steps, and the new Agentless system is already ranked 5th in this list, including the open source and the proprietary business solutions. So I think not bad for the first try of a no agent system in software development. Now, you know that maybe in some of those 300 datasets, in this benchmark dataset, there are some non-really specified tasks. So the researcher sit down and clean the dataset to go from the 300 tasks to 252 problems, and they call this new benchmark dataset here the Lite S. Maybe S stands for smaller. And they did run the tests again. So you have here the classical Lite, and here you have now the corrected Lite smaller. And now if you look again at here the tools and our LLMs, you see the performance increases. For the best Alibaba, we have 33%. It goes now to 34.5%. But also Agentless improves from 27.3 to 28.1. But you see the rank stays the same. It is 5th in both cases. So not bad for the first appearance of Agentless. And if you look now at this particular sheet, you might decide that you might give Agentless a try for your task in your environment for your particular configuration. Now for my green grasshoppers, what is SWE-bench? What is this benchmark doing? Here, a paper by Princeton University I would recommend here from April 5th, 2024 in this version, if you want to know more about these benchmark sets. And you remember I showed you also here the RAG solution here for software development. Just to give you a short explanation, maybe let's like a look at the performance. If we go here with the RAG as a tool and we use here Claude 3, you see we have a performance of 4.3%, with GPT-4 2%, and then if you go down with Claude 2, 3%, and all of this is below the threshold of 5%. So maybe if you look at other performance data here, you might have a second sort for the classical RAG configuration. Okay, just wanted to show you how does it work, exactly what you expect here. It retrieves relevant information from a database, a set of documents, whatever you have available. The file content retrieval mechanism is our simple BM25 algorithm, our very old friend. This system identifies the most relevant files from the codebase related to the software issue at hand. And then we have a patch file generation. Once the relevant files are identified and retrieved by the system, now our LLM directly generates a patch file. This patch file contains the code changes needed to fix the issues found in the retrieved files. And this is the way our RAG system works. So now that we had a look at the system, at the performance data, I was interested, how does it work? How is it possible not to use here some complex agent structure, but how can an agentless system give us this performance? Now you're not going to believe this, but the main idea is simple. We have just two aspects here. We have to identify where the problem in the code is, so we have a localization phase, And then we just have to fix these code problems. This is a repair phase. Easy. Localize it, repair it. Now, the localization phase, to give you a little bit more data here, involves a hierarchical process of a tree structure to determine the exact location within the code that requires some change. So the LLM scans here the entire code base and ranks the files based on the likelihood of containing errors related to the reported issues. The next step is to drill down here to specific clauses and functions within those files. Then the LLM reviews here the structure within each file, like clauses and function. And the final step is to pinpoint the exact line of code or code blocks where changes should be made. Or, as we can say, where we have to repair the code. And here, the LLM generates multiple potential fixes or patches for those bugs that we discover. But of course, the remaining patches are ranked based on their effectiveness, and the top ranked patch is selected and applied to the code base. Well, as easy as this is. Now, if you want to see it in the original location, it looks a little bit more complicated, but it is in principle exactly the same. But let's do it here on this original visualization. So the authors say we begin our hierarchical localization process by turning the project code base into a tree-like structure format that demonstrates the relative location of each file. Next, 2, using this repo structure format along with the original issue description, we ask the LLM to localize and rank the top and most suspicious file that need editing. And 3, we provide a skeleton for each file. This means a list of declaration headers of the classes and of the function, and ask the LLM to output a specific list of classes and functions that we should examine more closely to fix the bug. And then, step 4, we ask the LLM to finalize a smaller set of edit location. And for the repair phase that starts now, we provide the code snippets at these edit locations together with the issue description and ask the LLM to sample multiple patches to solve the issue. And then, step number 6, we perform some simple filtering to remove any patches with syntax errors. And then we use, for example, majority voting to rank the remaining patches, and Agentless then selects the top ranked patch as the final patch for submission. Sounds easy. The code is there for you. It is open source. You can try it out immediately. And you know what? There's one sentence I would like to show you from this preprint. The authors say, our work highlights here a current overlooked potential of a simple technique in autonomous software development, but that allows us also to interpret what is going on. Because if you have agents that go 30, 40, 50 turns, you can't really follow up with exactly what is happening in software development. But with Agentless, you can. So therefore, I highly recommend here GitHub Open Auto Coder Agentless, updated 2 days ago. Have a look here. As you can see, beautifully structured setup, localization, repair artifacts, whatever you like, MIT license, great. Plus, since this is a new paradigm, because me too, I'm used to using Agent for all of this, Devon and all of this. And now the authors come and say, let's think about this from a more abstract point of view. Do we really need agents? Yes, 2 years ago, we had to use Agent to find here the solution because our technology was not advanced as it is today. And they have 3 points I would also like to stress, and I quote here the authors of the study. And they say, the disparity between the human and the current LLM abilities leads to the following limitation of agent-based approaches. And they say, at first, we have a complex tool usage. And they said, to utilize our tools, current agent-based approaches apply an abstraction layer between the agent and the environment. And examples like mapping real actions to API calls so that agents can use tools by outputting an API call instruction. Those API call specifications require some careful design regarding input-output format, and this can lead to incorrect and imprecise tool usage, especially if you have a real complex action space. So this means, given the iterative nature of agent-based approaches, where the current action depends on the previous turns, if you have some incorrect or imprecise defining or the using of a tool, this will reduce the performance and incur additional costs. Second, they state, we have a lack of control in the decision planning. Because in addition to using now the tools, the agent decides the current action to take based on the previous action taken and the feedback provided by the environment, but often with minimal checks to ensure that the action taken makes real sense. And due to the real large possible action space and the feedback response, it can be extremely easy for autonomous agent to become confused in this huge action space. And maybe they offer or perform suboptimal exploration. And I've seen this also. So they say, furthermore, to solve here an issue, an AI agent here in the software development can take upwards to 30 or 40 turns, which makes it extremely difficult to both understand the decision made by the agent and also debug it. And this is true if you started here to debug those agent system and LangChain+++, you will find that you can spend a lot of time on exactly this point. And the final point I would like also to quote from the authors is here, a limited ability to kind of self-reflect, Because those agents, they tend to take all the information, all the feedback from an environment, but they do not really know how to filter out incorrect or irrelevant or misleading information. So a common step in the agent-based approach is to reproduce an issue with a minimal test case. But however, this reproduced test case may not be always the correct or the precise test case to apply to this particular problem. And this means that if we have an incorrect step now taken here, this step can easily amplify and negatively affect all future decisions taken by our AI agent here in the area of software engineering. So I think those are three valued, powerful points. Maybe if we have the technology to reduce AI agent use, to cut back on the agent complexity, because whatever we reduce the complexity in a system, it is less prone to make mistakes, to errors, and therefore it is so much easier for us to debug the whole system. So I think an interesting study, a very new ideas presented here in this preprint. The code is open source. Go there, experience it yourself for your case, for your particular task, in your computer environment. Give it a try. If the data that the researcher present here, especially here, the benchmark data, are solid, it is the best open source element that we have today for software development. So I think this sounds really interesting. And from the idea why they implement it and how they implement it, I think it is really important to at least be brave enough to break with our tradition of AI agents and explore a new technology. I hope you found it interesting. I hope you have some new thoughts about here, software engineering, and it would be great to see you in my next video.